All right, so let's talk about the quiz tomorrow. I want to talk about what's in the quiz tomorrow, and then I also want to go through a little bit of review of how to do those particular things. So we're going to start with types of reactions. There are 5 of them. You will need to be able to identify combustion, single replacement, double replacement, synthesis, and decomposition reactions. Now, that should follow directly from your notes. Remember, on your notes, we had that big chart of kind of the general format for all of these. And at this point, you've seen enough that you should be able to quickly recognize what type of reaction it is, just the type. Okay? Of those 5, what kind of reaction is this? The next thing we talked about was balancing. And now if I give you an entire reaction with all the different bits and pieces, regardless of the type of reaction, you should be able to balance that. What tool do we have for balancing reactions? What can we change when we get down to balancing a reaction? Coefficients. Right? So once you have balanced bits and pieces in your reaction, then you can go to the coefficients and ping pong back and forth and balance that reaction. Now, in your notes, there is that 6-step process. If you get one that's really gnarly, you can use those steps, right? Putting the grids down, counting up the different pieces on both sides of the equation, slowly and methodically, balancing one thing, fixing the sodium, and then recounting everything on that side of the equation until you balance both of those charts. So you have that tool available, but sometimes you can just, put a 2 on this thing and a 3 on this other side, and poof, everything is balanced. If you can do that in an equation, great. There's no reason to do all of the rest of the stuff if you can just put a 2 here and balance it. For that matter, make sure you check. Some of these just start balanced. Like you might not have to do anything, like just writing down the different formulas for the compounds might make it balanced. On this quiz tomorrow, we'll be predicting products. For these 3 types of reactions. Single replacement, synthesis, and decomp. Why did I write? Double replacement and combustion are not on this yet. We just did the lab yesterday for double replacement. That will be coming soon. But for the quiz tomorrow, just these 3 types. Single replacement, which again, we did that lab where we did single replacement. When you have one element trying to kick another element out of an existing compound. You have synthesis, just putting 2 things together. And then you have decomposition. So the important part for these, what is the tool that you use to predict these products? The purple paper. Okay, and I think tomorrow, for the purpose of the quiz, it might be blue that I hand out. But this sheet. Now this sheet is not useful unless you know how to use this. Right? So what part of this sheet, front or back, do we use for single replacement reactions? What part of this do you need? This bottom part, right? The activity series. How do we use that?
If it's above, it replaces.
Yes. So when you have 2 candidate metals, let's say, when you have zinc trying to kick copper out of some compound, you need to use your sheet to figure out, hey, will this or will this not happen? If it will or won't, I can identify that with the activity series on this sheet. So we're going to do a couple examples of these in just a moment, but let me put the last thing that is on the quiz. Remember, we have somewhat resurrected diatomics from their resting place in your notebook about 40 pages ago. And this directly relates to these things up here, because if you have a decomposition reaction, and let's say oxygen is one of your products, oxygen would be a diatomic element, so even though it says oxygen on your purple sheet, you need to know that in that equation it's going to be O2. Right? If you had a single replacement reaction and let's say chlorine replaced bromine in some kind of reaction. Well, bromine is diatomic, so on that right-hand side where now bromine will be by itself, it'll be Br2. So diatomics is part of this. Again, something you need to know, but not necessarily, I won't be asking you, hey, what are the 7 diatomic elements? That was October.
It'll only have like the O2 or F2 and 5 solid.
Correct.
Well, it's from nitrogen down to bromine
Yeah.
and then hydrogen.
It looks like a 7 on the periodic table plus hydrogen, yes.
Oh, I know.
So let's try one. Let's do so based on this, what kind of reaction would this be? Single replacement. How can you tell?
Because there's just, I can just know.
You can just
I'm locked.
tell. Henry is locked, so he can just tell. Yeah, so the zinc here, is targeting the copper, right? Targeting the copper for replacement. How can we then tell if it will or will not do something?
Purple sheet.
Purple sheet. So which of these two is higher?
Probably zinc.
Probably zinc. Zinc is in fact higher than copper. So what will happen over here? Now, we've made something new, right? We've made zinc nitrate. No, it's not. So now that we've made something new, we need to use oxidation numbers to balance these new products. Just balancing the products. We don't balance the overall equation yet. We have to worry about what we've made first. So what do we have to do here? Because zinc is a +2, it's a -1, and away you go. Do we have to do anything with the copper?
No, sir.
No, it is not one of the what? It's not a diatomic element, so we just leave it alone. Correct. So that's it. That's single replacement.
That's all we had to do.
That's it. All right, so let's identify this equation. What kind of reaction might this be? Synthesis. This is two things coming together. We're not replacing anything. We are just combining these two things together. So what is that going to create? Silicon bromide.
Good job.
Are we done? No, we need to do the check for the oxidation numbers here. What's the oxidation number for silicon? And how about bromine?
-2. -1. I knew
Minus 1. So what is the resulting formula for this compound? SiBr4. So now that we've figured out the formulas for the compounds that we've created, or a compound in this case, the last step is what? Balancing the equations. We can modify coefficients. In this case, how do we balance it? Just a big 2. So look, we've figured out here, we've identified the kind of reaction. This would be synthesis. We've determined what the product would be. We've balanced that product's formula. And then lastly, we balanced the overall equation. That was composition.
Oh, yeah.
Lastly, let's do one that's not really easy. What kind of reaction could this possibly be of our 5 types? Decomposition. This is one thing. We're not replacing anything. We're not adding 2 things together. This surely isn't combustion. So in this case, we're going to have decomp. So again, what tool do we need for decomp reactions? Purple sheet. What rule on our purple sheet is going to apply to this decomp reaction? Rule number 3. What does it? Rule number 3 read?
I don't know. I don't have my purple.
You're locked, Henry. It's very impressive.
Love you, Cookie.
What's that? So a metallic hydroxide will decompose into what? Metallic oxide plus water. So what's a metallic oxide going to look like here?
ALO.
ALO and? Okay. So now we've got some new products. Let's balance just the products. How's ALO? Bad.
Aluminum's like what? -2?
Plus 3. Oxygen is a -2. So crisscross, right? And how's H2O? We know H2O is fine for water. So what's our last step here? Balancing. How are we doing on balancing?
Almost good.
Almost good.
We need 3 waters though.
What?
We need 3 H2Os.
Maybe. Let's fix the aluminum first, is my advice here.
2.
So we have 2 here. Now, how do we fix?
I was right.
I know, Henry. You guessed rule 3. You guessed out of 3. I'm just guessing. 3 is
No, I knew that was 3.
3 is just your number
I
here.
guessed that rule 3 though. I was a guess that one.
Your guesswork is legendary, Henry.
Thank you.
All right, so that's it. That is a decomp reaction. Again, you're using your purple sheet. You're creating some kind of new products. You make sure to check the products first, that the actual formulas are balanced. And then once you've done that, then you can balance the overall equation. Questions? So all of this is driven from our purple sheet, right? Helping us to predict products. This is the tool we need. You also have the worksheet that we did on decomp and synthesis reactions. You also have the lab that we did on single replacement reactions. You also have, I'm sure there was a worksheet or 2 in there on single replacement reactions as well. And then lastly, if you need that review, make sure you check out which elements are diatomic, so you know this. This is something you need to have memorized. NOF, ClBrI, and then hydrogen. Makes us 7 on the periodic table, plus hydrogen.